Hello guys! Welcome back to my YT channel. This is your content creator, Sultan. So our topic today is the chemistry of quantum numbers. Welcome to my world of science, health, safety, and music. Uh, Alright, so oh my gosh. So I need to write now my title. So after my discussion, I will be able to erase, okay, and then write again. So it's up for you to follow. Right? Okay. Hello guys. I'm coming back from my discussion, right? So things like so our topic for today is chemistry of quantum numbers. Right? Hello guys. Chemistry of quantum numbers, right? Okay. Okay, our topic for today is chemistry of quantum numbers. Okay, so I need to off the AC now. It's really cold. Hello guys, welcome to my YT channel, Science, Health, Safety and Music. Our topic for today is quantum numbers, okay? Okay, this quantum numbers topic are discussed in general chemistry lecture 1, and then after that we had finished our study. Then we need also to study this back in relation to physics. Okay, physics, because physics is a branch of science that deals with the study of the matter and also the energy involved. Okay, matter and energy. So the energy of this, okay, electrons, protons, neutrons in an atom, things like that, because these particles, or shall we say elementary particles, protons, electrons, neutrons, are moving. Okay, you get the point. So in studying quantum numbers, we need to understand the framework of the atom, things like that, right? Before anything else. Things like this is, for example, this is one atom. Okay. Okay. This is one atom, but this is very small in reality. I'll just draw this very big for the purpose that we can understand really, right? Okay, so this is one atom. So if you mean one atom, so this is also equivalent of one element. So meaning to say each element made up of a single atom in a definite and a fixed proportion. Okay, so things like that. Again, an element is made up of and composed of one atom, banded, or let us say fixed, okay, in a particular ratio or proportion. Okay, for example, get the point? So we have here the atom here, right? Things like that. Okay, so if this is an atom of, let us say, chlorine, right? And you love chlorine that much, right? Chlorine. Oh, so chlorine. Chlorine is a halogen family under group 7A. So we need to say it has valence electrons of 7. The group will specify the number of valence electrons and its valency. So the valence electrons, or VE, let's just write this capital V and smaller e, right? Okay, it's equals to 7. So electrons, we will write that small letter e with and small underline at the top of letter E. So 7 electrons. Okay, things like that. Okay, one atom of chlorine. For example, this is chlorine. Okay, and then if you can remember fluorine, chlorine, so it's gonna be on the third or on the second. So we need to remember the arrangement of the periodic table so that we determine the energy level of chlorine. Okay, things like so. Say this is enough, for example, only for the purpose of discussion because it will travels us a lot. Okay, if we try to touch one topic, another topic, another topic, and then it will be related in this single atom only. So, you know, it will be a lengthy discussion. Actually, chemistry is very broad. It is the science of all sciences, meaning the parent of all sciences, things like that. The core background, the source foundation of sciences is chemistry. Okay? So it's very enjoyable if you love chemistry, okay? Things like that. Okay, now this is an atom. So we have here, for example, this is the outermost shell, right? And then we have also another shell. Example only, right? For example, I don't have the table in my hand now, so I cannot determine the, you know, the exact number of shell. Okay, like that. Let's say, for example, that chlorine is in the, you know, the period number 3. Okay? Chlorine is in group number 7A, so that would represent the valency, the group 7. So we need to say the chemical properties of chlorine will share the same properties with fluorine, bromine, iodine, acetylene because, you know, the chemical properties are dependent to the valency or the valence of electrons, the group, the column, you know, the vertical column. Okay, now if we talk about the horizontal, the rows, the period, right? So the period also are the numbers that could determine the shells. Okay, the shells are the orbits. For example, chlorine belong to period number 3. So there are 3 shells of chlorine. So this is now our example. Okay, shell number 1, shell number 2, and shell number 3. And we have 1, 2, 3. Or shell would mean, remember this because if you are a little bit confused in our chemistry, then our scores will be lower, especially in our board examination. Okay, in the future after, for example, if you're studying BS chemical engineering, if you're studying BS chemistry, then during the, you know, what they call one? Cumulative, no, it's commutative. What we call that one? Meaning the summative examination is what we call for that. Summative examination is the last stage of exam of all your exams in your first year, second year, third year, fourth year, fifth year, like that. So summative test is a comprehensive test that will test you that if you are really legit and certified engineers after your 5 years of engineering in different universities and institutions in the Philippines. Okay. So if you're taking BS Chemistry, 4 years of study. If you're taking also BS Chemical Engineering, it's 5 years because we are talking about chemistry. These are the courses related to science, the chemistry. So after that, after all your exams, everything, prelims, finals, midterms, the last summative test to calibrate and gauge our academic competence to practice our profession is the board examination or the licensure board examination. That's why after that, if we pass, we are given a registration card so that we can practice and registered by our government to practice our profession. Okay, things like that. So these kinds of discussions are very, very important in summative comprehensive test in your last stage of examination as a student. That is also the same thing as last stage of examination as a student. And after that, you will go to the real world and applying different companies, things like that, in pertaining to your profession, right? Things like that. So we need to combine this knowledge while you are still, actually, while you are still in high school, because chemistry is was taught in high school, right? So you can develop more in your college. Okay, first year college, right? Yeah, first year or second year college. First year college, first semester, second semester, right? Okay, so because there's also laboratory for this. Chemistry lecture 1, laboratory 1. Chemistry lecture 2, laboratory 2. Okay, so for us, PS chemistry and this chemical engineering, we have still another extension of a lot of chemistry. Physical chemistry, quantitative chemistry, qualitative chemistry, and organic chemistry. But for others, engineering students, okay, but actually all students, all courses must have chemistry, the basic chemistry. Okay, it is now it is really inputted in your prospectus, but not a detailed one compared to the science professionals, BS chemistry and BS chemical engineering. Okay, things like that. Going back to the discussion. So if we mean shell, that is also on energy level. Okay, energy level. Okay, now if you say outermost shell, so this is the 3 because this is the last shell, right? So this is the outermost shell. You get the point? Things like this. The outermost shell is the energy level number 3, right? And shell is equal to the energy level. Okay, let's say. So this is for chlorine. So example. So if chlorine is in period number 3, okay. The atomic mass and atomic weight of chlorine is 35.45 gram per atom. Okay, things like that. Okay. You should also memorize chlorine because chlorine is a basic, basic mineral. The chloride basic mineral and chlorine is a basic element, non-metal. Okay, this is part of the 12 non-metals in our periodic table. If you can still remember, I discussed that last 3 days ago. 18 elements. We have the non-metals and we have the metals like that. Okay, categorically we have 12 non-metals. Okay, 7. Okay, we have 7 the non-transition metals. Wait, 7. Okay, not non-transition but the part beside transition we have the metalloids and semiconductors. Okay, because there's a lot of transition metals. Okay, going to the for example the left part of the periodic table. Sorry guys, because I don't prepare the whole writings because my whiteboard is small. Okay, so I'm just attacking the discussion through my acquired knowledge and stack knowledge. So so it's very difficult also sometimes to deliver a topic or various topics that was discussed 30 years ago. And then 20 years ago, okay, 2000, 23 years ago after my graduation, things like that, okay? So that's it. Okay, because there's a lot of parts of the transition. We have the noble gases. Okay, we have the non-metals. We have the alkali metals. Alkali, alkali metals. Sorry, wait. Okay, alkaline earth metals. The actinide series, the lanthanide series, like that. Lanthanide series. Sorry. Okay, the halogen family. The halogen family is very popular, right? Okay, things like that. These are the halides. Okay. Now, the importance of chlorine is very important in our central nervous system to help create electrical impulses, okay, to generate the appropriate hormones in order for us to act, behave, and to give us energy. be activated between the messaging and the sending of message into the central nervous system. It's the function of the hormones. Then the vital organs will signal and it will be delivered and transmitted to the brain like that. And if there's no electrical impulses, then all things are not possible to produce any actions. Okay, walking, writing, running, cycling, and everything. If there's no chlorides, problem. If there's no sodium, if there's no potassium, then there will be no electrical energy or electrical impulses because our body process our electrochemical processes. Electrochemical process, and in the word chemical it involves biochemical reactions. So to make it short, the bio there would be under the chemical. So if you try to be strict, electrobiochemical processes, but it should be also understandable. It's just the same to electrochemical processes inside our body. Okay, but the required electrical energy is not used with power plant or electrical power source companies. It's just very small, enough only for us to become active, to become energized, to become healthy. So that's chloride's function. And chloride's, of course, under chlorine. That's why we need to study also the physical properties and chemical properties of chlorine. So going back, okay, so we have the first shell, the small circle in the center of the atom. One, two, three, like that. Okay? Okay, guys? Okay. Now we have here the center. The center. What's this center all about? So this is the nucleus. Okay. Let's put letter N, nucleus. Okay, things like that. And each shell or each energy level, okay, again, we can determine the shell and energy level based on the period number, horizontal row of the periodic table. It happens that chlorine is in the period number 3 for the purpose of discussion. I'm not really exact at this because I don't have the periodic table in my hand. Okay, but if you try to verify the real and actual position of this chlorine, it could be in the number 3 period, but I am sure it's in the group number 7 because this is a 7A family, halogen family or a halide family member. Okay, and this is the second most electronegative element of all 118 elements we have in the periodic. Okay, based on Dmitry Mendelev's study, okay, things like that, because he based his on the atomic mass and atomic weight. He said the periodic table is a range of atomic masses and atomic weights, things like that. Vital atomic weights, it has to do something with the chemical properties in which group of elements are arranged really in the valency, based on the valency, the valence electrons within the particular group of our periodic table. Okay, things like that. You get the point? So, by the way, before going further, Dmitry Mendeleev is the father of periodic table. Okay, he is called the father of periodic table. Things like that, in which he discovered first the 20 elements. Okay, and then later on it became 118 with a collaboration of Henry Moseley. Okay, so don't interchange this when you take the exams. That Henry Moseley is different study of Dmitry Mendeleev, but he used the concepts of Dmitry Mendeleev. He's just tried to enhance and improved the study of Dmitry Mendeleev. Things like that. So in short, this Henry Moseley is the predecessor. Okay, it's the predecessor of Dmitry Mendeleev. Okay, so now this Henry Moseley is the father of modern periodic table. Be careful also sometimes examination because there will be like that, and you're going to answer directly Dmitry Mendeleev. Take note the sentence how it's being phrased. If the question will say the father of periodic table. Okay. It doesn't specify the adjectives, whether it is ancient, old, or modern, or new. Then you have to answer Dmitry Mendeleev. If the question will say, what is the father of modern, there's an adjective, okay, modern or new, like that, then it's gonna be Henry Moseley. Okay, Henry Moseley, I think he is an Italian chemist, whereas this Dmitry Mendeleev is a Russian chemist based on my research, things like that. Okay, now, so Henry Moseley described that the elements in the periodic table are arranged in atomic number, in which it's very easy to recognize a bit compared with the Dmitry Mendeleev. Since the whole concepts of this periodic table thing came from Dmitry Mendeleev, that's why he is a little bit superior than mostly the general name or the popularity or the recognition or the merit will be given to Dmitry Mendeleev as the father of periodic table. You get the point? Okay, things like that. Then we have the nucleus in, right? Okay, the nucleus in the center would involve protons and the neutrons. You know, it looks like they're banded together in the center. So protons, neutrons, like that. So this is the quantum number. I'll just discuss a little bit of overview because when we go to the quantum numbers, we cannot understand precisely if we cannot understand really the behavior of these elementary particles, things like that. So it's really a requirement to discuss, right? And after that, we can discuss specifically quantum numbers there, okay? So it's a sort of, overview, right? Or pre-discussion of quantum numbers, okay? Things like that. So prior pa ka, no? Okay, so we have protons and neutrons, okay? Here, protons, I will put it, protons and neutrons. Just go with the straightforward information. Never mind my grammar. Okay, never mind my pronunciation and enunciation and diction. Focus directly to the content. Okay, the technical aspects, things like that. These are more important. Okay, get the point. Things like that, protons and neutrons. So they are banded together. The main reason, okay, because their masses actually are very closely related to each other. Okay, so if you will recall in our chemistry, because I don't forget this really, okay, so the mass of proton is 1.666 something, things like that, times 10 to the 27 kilogram. We are talking of the mass of the proton, okay? You get the point. We are not talking of the atomic mass. You get the point. Things like that. The mass of neutrons is going to be 1.67 blah 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 and everything times 10 to the 27. They are more closely related. Okay? Things like that. Okay, so that's why they are banded because of their masses. Okay, now in each shell, shell 1, shell 2, shell 3, of the energy level, then the electrons are there, surrounding electrons. This is now the emphasis of our quantum number. It has to deal with the electrons. So, related also to our Lewis dot structures, that it talks about electrons. Okay, understanding of electrons in science and chemistry is really very, very important because without electrons, we don't have light. We cannot power the world with garish and gleaming and bright light. Then we cannot enjoy, okay, the earth, the various activities in the earth if there's no light. So to understand that further, we need to really study electrons. Okay, that's the benefit, that's the faida, why we need to study the electrons. Okay, things like that. And not only that, electrons are very important component in the manufacture of different electronic products, such as your cell phones you use now, laptop, appliances like that, flat screen TV, everything. These are really made up of electrons in the first place. Okay, you get the point because metals are made up of electrons, things like that. Okay, in a particular atom. Okay, you get the point. Things like that. You just don't see it, but it's in there. Okay, you get the point. Mm. Because normally as a person, we love to see what we see outside. We don't love to see what we see inside. That's why sometimes we normally judge the people because we don't see the inside of the particular people. The atom and elementary particles are just like that also. So we go on the deeper, on the inner part of a certain individual, and that's their attitude. Okay, you cannot distinguish the attitude by just looking at the first. You can usually observe that for how many months, how many years, like that, or through series of going together in company with each other, then you can determine the true character, personality, and behavior of a people or a person, things like that. You know, atoms also are just like that. The inner part of it we must study, not only the outside. You get the point? Oh, we have a lot of electrons in the shell number 2, or the energy level number 2. And now we go to energy level number 3. So we have also electrons there. One like that. This is the purpose of discussion because in actual discussion of quantum numbers, there are specific electrons that can hold in